All right, what we're going over today is lesson 20 and 21, dealing with an introduction to radicals and also rational exponents. A rational exponent is just simply an exponent that's in fraction form. Now, before we look at some radicals or rational exponents to evaluate, let's go over how to convert from a radical to a rational exponent. So let's say you're given a radical with a root r and a base b and e for exponent. And you need to convert this into a rational exponent. So you just have your base. And to get the fraction exponent part, just take your given exponent. And oftentimes you might not see an exponent under the radical. That's understood to be to the first power. So the fraction part is your exponent divided by your root. Let me copy and paste the first set of problems. And you can either use your calculator for problems, the second, third, and fourth problem, or you can do them by hand. It's up to you. The first question, it says find a decimal approximation for the radical. We do not have a fifth root button on our calculator, so we have to convert this to something where we can put it in our calculator. So let's change this to a rational exponent form. That 45.7 is understood to be to the first power. Now, to rewrite this as a rational exponent, it would be 45.7 raised to the 1/5 power. Now, 1 over 5 uh, converts to a terminating decimal. So if you want to change this to 0.2 before you put it in your calculator, that's a good idea. Depending on what type of calculator you have, or if you use your cell phone's calculator, the exponent button may look different. You may have an x to the y key, or you may have a caret or a rooftop key. Now, for most calculators, put in your 45.7 first, and then hit your exponent key. And let's see if I can share my calculator. Hold on just a minute. Yeah, here we go. So I'm typing in, oh, I need to change mine to scientific. If you use your calculator on your laptop or desktop, if you use your cell phone's calculator, you have to turn your phone sideways so all the other buttons will appear. So I'm doing 45.7 and then my exponent key and then my exponent 0.2. And let's say we wanted to round our final answer to the hundredths place or out to 2 decimal points. So this would be approximately 2.15. So if you have to evaluate something with a root other than a square root, then you'll have to convert your radical to rational exponent form. The other examples are already in rational exponent form, and you can either use your calculator or for the first couple of problems, I'll use just do it by hand. So right here, this is the same thing as the cube root of negative 343. Now, many calculators also have a cube root button, so you can just enter this into your calculator directly. So let's see here. Okay, I actually have a root y radical calculator button where you can type in your root first and then enter your number that's under the radical symbol. Excuse me. So this one is not going to come out so nice and easy. Again, you will probably have to round to a specific place value. Let me enter it the other way. Let's say 343 negative. And we need to enter our exponent. So we hit our exponent button next. Now, unlike 1/5, 1/3, y'all already know is not going to be so nice as a decimal. So we need to use parentheses and just enter 1/3. Close your parentheses and then mash equal. Now you actually get a different answer, and let me explain why. Some calculators are very sensitive and actually do order of operations out of order. So if you have an exponent that's a fraction, make sure you use parentheses to get the correct answer. So -7 is actually it for the second problem. Third question, you can either use the calculator or let's say we need to figure it out by hand. So let's rewrite this as a radical. Our root is 4, and we have 81 to the third power. Speaking of order of operations, you work from left to right. That means you find the fourth root of 81 first, and all you do is ask yourself, what number can you multiply 4 times to give you an 81? And that's going to be a really small number. It's going to be a really small number. It's actually going to be 3. So this part here is 3. Now we need to cube this. So 3 cubed will give you 27 for that answer. And I'll just ask my folks here on campus, are there any questions so far? All right, let's look at the next one. Again, let's say you do not have a calculator up handy. So let's try working this out by hand. So let's convert this to radical form. This will be the fourth root of 625. And through just mentally guessing, the fourth root of 625 is actually 5. So a lot of these you can actually do by hand, simply converting to a radical first. Now, if you have a negative exponent, don't use a calculator because my math lab wants an exact answer, likely a fraction. So whenever we have a negative exponent is the same thing. Let me go over the negative exponent law with y'all. If you have a raised to some negative x power, then that's the same thing as 1 over a to the positive x power. So it's actually reciprocal. Using this exponent law, let's rewrite our problem as 1 over 81 to the 5/4 power. Now for that part of the problem, you can use a calculator. So we'll just type in 81, hit our exponent button, and just to be on the safe side, to make sure our calculator does not go out of order, let's put our fraction exponent in parentheses. So left parentheses, 5 divided by 4, and then hit equal. So that's your denominator for your as part of your final answer. 1 over 243. On campus, are there any questions about evaluating radicals? All right, let me look at my notes and see what is next. We have an application problem and also a question where we have to also convert a radical into a rational exponent. Let's do the second one first. That will take the least amount of time. Write with radicals. Assume that all variables represent positive real numbers. So all we do here is put your root, which is understood to be root 3, in parentheses. The 3y plus x goes under the radical sign. And the exponent 5 goes under there also. That's all you have to do with this type of problem. The first question is an application problem involving circuits. The formula I equal to the square root of 2p over L relates the coefficient of self-induction L in units of henries, the energy P stored in an electronic circuit in joules, and the current I in amps. Find I if P and L are given. In your formula, plug in P and L. So P is 90 and L is 70. So we got the square root of 180 over 70. And you can just put that in your calculator exactly like it is. So I'll do 180 divided by 70. Get that decimal answer. And then take the square root of it. So when we take the square root, we get approximately 1.6 amps. So that problem wasn't too bad. Just use the formula, plug in the given values to find the missing value. Are there any questions on campus with these two problems? Okay. All right, the next batch of problems, we must use some of our exponent laws. And before we work out this question, let's go over the various exponent rules. Beginning with the product rule. Product rule states if you have a product with the same base, you keep the common base and add your exponents. Quotient rule is the next one, and it's the exact opposite of the product rule. If you have a fraction with the same base, then you'll keep the common base and subtract your exponents. The negative exponent law I already went over with y'all, but I'll put it up here again. If you have a to the negative x power, then that's the same thing as 1 over a to the positive x power. And the last rule we haven't used, I don't think, in here at all, the power rule. With the power rule, if you have an inside power and an outside power, then you multiply the exponents together. So if you have an inside power raised to an outside power, then you multiply the powers together. Now let's get back to our first problem. Simplify the expression and write your answer with positive exponents. For the top, use the power rule. So we will take 1/2 and times it by 10. And also take with the y, multiply 3/5 also by 10. With w, 1/2 of 10 is 5. And with the y, 5 can go into 10 2 times. And 3 times 2 gives us 6. Let's bring down what we have so far. Up top, we have now w to the 5th power, y to the 6th power, all over w cubed. The last rule we can use is the quotient rule with the letter w. We'll subtract the exponents, and because the larger exponent is at the top, then that's where our squared also goes. So our final answer is w squared y to the 6th power. Any questions here on campus before we look at some more problems? All right, let me copy and paste the next batch of examples to our whiteboard. Next question to the far left, same directions as before. Before we deal with the numerator, we have to use the power rule for the denominator. So we multiply each inside exponent times the 1/2. And the n down there is understood to be to the first power, so that's just 1/2 times 1. Now, going back to the m, the 2's cancel out. So we have just plain m to the first power and n to the 1/2 power. Now, to convert negative exponents into positive ones, you're using the reciprocal concept. So if they're negative and they're on the top and you need to change them to positive exponents, well, the opposite of numerator is denominator. So we'll move both the m and the n to the bottom. And all that leaves up there in the numerator is just 1. So we have m to the 3/4 times m to the first power times n to the 1/2 times n to the positive 1/4. For each letter, we now must use the product rule. So the product rule means you add the exponents. Now 1 plus 3/4 is 1 3/4. Or that's the same thing as m to the 7/4 power. And for the n's, you don't even have to get a common denominator. Use money to help you add the fractions quite easily. 1/2 is the same thing as 50 cents. And 1/4 is 0.25 cents. So that's equal to 75 cents, which if all you had were quarters in your pocket, that would be 3 case quarters, or n to the 3/4 power. So this is our final answer, 1 over m to the 7/4 times n to the 3/4. Are there any questions about the first problem in this group? All right, let me go over the second problem with you. Make some room first by erasing everything. The next question also has the same directions. Now, before we deal with the fraction, let's deal with the second part right here. That's easy to simplify because we're taking each exponent on the inside and multiplying it by the -1, again using the power rule. So that becomes now b to the positive 1/4 and c to the positive 1/4. We're also using the power rule to simplify the fraction. So we'll take each inside fraction and multiply it, or each inside exponent, and multiply it by the outer exponent. All right, so for the b as in boy, the 3's cancel, leaving us with b to the negative 2 power. And in the denominator, nothing cancels. We just multiply straight across. And that gives us c to the negative 15/4 power. Now, turn each negative exponent into a positive one by flip-flopping the letters around. The b to the negative 2 goes on the bottom now, and it becomes b squared. And the c to the negative 15/4 power moves to the top, and it becomes c to a positive exponent. Now, to simplify the b's, use the quotient rule. So we'll subtract the exponents, 2 minus 1/4. Now, I'm going to show you a very neat trick here that always works. 2 minus 1/4, that looks like a mixed number. Well, we can change it to an improper fraction. So 2 times 4 gives us 8. And 8 minus 1 gives us 7/4. So we have b to the 7/4 down here. The reason why I put the 7/4 down there is because when you subtract exponents, you always put your result where the larger exponent was. For the c's, use the product rule by adding your exponents. And we get 16/4, which is to the 4th power. Final answer, c to the 4th power over b to the 7/4 power. On campus, any questions about this example? All right, here we go with the next problem. Let me make some room for us to work. The directions are the same again. The first thing we need to do is distribute that outside term times everything on the inside. Normally, I don't show what we're distributing, but here it's a good idea. So we have 2a to the 11/5 power times a to the negative 11/5 power plus, now I'm distributing the outside term to the second term, and we have 2a to the 11/5 power times a to the negative 1/5 power. This is the rare time you don't have to change your negative exponents into positive ones. You can simply use the product rule each time. So right here, when we combine our exponents, well, 11 over 5 minus itself is 0. So we have 2a to the 0 power. And by the way, we know what a to the 0 power is. Any non-zero base raised to a 0 power is automatically 1. So this is 1 right here, and that turns into 2. For the second part, use the product rule again by combining, in this case, subtracting your exponents. So 1/5 from 11/5 is 10 over 5, which is 2. And that gives us 2a squared. I don't remember if my math lab wants you to factor your answer, but just in case, we can take out a GCF of 2 out of both terms. So when we take out a GCF of 2 out of both terms, we're left with 1 plus a squared in parentheses. Any questions here on campus? Okay, next batch of problems includes another application problem, as well as 2 questions where we use use one of our exponent laws. If you have a radical inside of a radical, or if it keeps going even more times than that, start from the inside and kind of set it up, work your way out. Now that cube root of m is understood to be cube root of m to the first power. So we can rewrite that as a fractional exponent. That would be m to the 1/3 power. Now that big fourth root, it also has an exponent understood to be 1. So for that bigger outer root radical, we can rewrite that as a fraction 1 over 4. Multiply the exponents by using the power rule, and we get m to the 1/12 power. Now, if you change your answer back to a radical with root 12, the 12th root of m, and my math lab marks it wrong, please alert me and I'll give you full credit. Now, off campus or even on campus, you probably see a little neat trick here. Our root is 12 in our answer. And no coincidence, if we multiply the given roots, we get our answer. So that's a neat shortcut you can use. Now the other question, let me make it bigger. Remember with roots, if you don't see a root or an actual number there for the root, it's understood to be root 2. So let's use our little shortcut here to easily get our answer. So we'll multiply all the roots. And just like that, we got our final answer, the 30th root of y. And just in case my math lab wants your answer as a rational or fractional exponent, this will be y raised to the 1 over 30 power. Again, if my math lab marks one of these answers wrong, please notify me and I'll give you full credit. Any questions about the root inside of a root problem? Okay. Word problem. And the day that I'm recording this lecture, this is very appropriate because it's pouring rain outside. Meteorologists can determine the duration of a storm by using the function defined as shown, where d is the diameter of the storm in miles and t is the time in hours. Find the duration of a storm with a diameter of 9 miles. All you do here is take your given function and replace each d with 9. Now the 9 to the 3 halves part, we can do that by hand. Turning that into a radical, that's the same thing as square root of 9 cubed. Work from left to right, meaning you take the square root of 9 first, and that gives you 3, and then cube it. So that part is actually 27. Now let's take 27 and multiply it by 0.07. So the storm will last just shy of 2 hours, exactly 1.89 hours. And that makes sense. If the diameter is 9 miles, that's quite a big storm. So it's going to take a minute for it to blow over. Are there any questions about the word problem? Another thing you'll see in this same section is if you're given a radical and you have to simplify it. For example, we have the 10th root of x raised to the 90th power. The simplest way to break down a letter is take your root and divide it into your given exponent. So 10 can go into 90 9 times with a 0 remainder. The division is quite simple each time, but the division reveals quite a bit of information. Your top number is your exponent that goes outside your radical. And your remainder is the exponent that stays inside your radical. Well, because our remainder is 0, that means there is no x remaining inside the radical sign. That 9 means exponent-wise, that would be x to the 9th power outside the radical. Let's look at another example. Excuse me. Next example, we have the square root of c as in cat, d to the 8th power. Remember, if you don't see a number for your root, it's understood to be root 2. And that c is understood to be to the 1st power. Now, if your exponent is less than your given root, then you don't have to do anything at all to that letter. So that c stays under the radical sign. To break down the letter d, you take your given root and divide it into your exponent. So we'll divide 2 into 8. That will go 4 times with a 0 remainder. Our division tells us exactly what to do here. The top number is the exponent that goes outside the radical. So that would be d to the 4th power. And since we have a 0 remainder, that means there are no d's left inside the radical. So d to the 4th power times square root of c is your final answer. Are there any questions here on campus before we look at some more radicals to simplify? Of course, the exponent, not all exponents are going to nicely divide by the root, as is the case here. We have the cube root of w to the 11th power, y to the 15th power. Again, to simplify letters or variables, take your given root and divide it into the exponent. So for w, we'll divide 3 into 11. Excuse me. That will go 3 times with a remainder of 2. What this means is your top number is the exponent that goes outside your radical sign. So that would be w cubed. And the remainder is 2. That means w squared is going to remain on the inside of the radical. Whatever root you're given or started with, you have to bring it straight down. Do not leave it off. Now let's break down the y in similar fashion. We'll take 3 and divide it into 15. So 3 can go into 15 5 times with 0 remainder. That means a y to the fifth will go outside the radical sign. And since we have a zero remainder, that means no y's remain under the radical sign. So this is your final answer. Are there any questions before we add some numbers to this? All right, let's add some numbers that we need to simplify as well. Let's start with the square root of 25. A is an apple to the sixth power. The square root of 25, as we know, is a perfect square root. That's equal to 5. And to simplify the a, take the given root, which is understood to be 2, and divide it into 6. So 2 can go into 6 3 times with a 0 remainder. Now we know that 3 means an a cubed is going outside the radical. And the 0 or the remainder indicates there's nothing left under the radical sign. So 5a cubed is it. Let's look at another problem. We have the square root of 300, c to the ninth power. Now, square root of the number 300 is not a perfect square root, but one of its highest factors is. We can break down 300 as 100 times 3. Because we know the square root of 100 is 10. So a 10 will go outside the radical. Leave a little space behind 10 in case you have to move a part of C out. And the 3 stays inside the radical. Now to break down C, take the root 2, divide it into the exponent 9. So 2 can go into 9 4 times with a remainder of 1. The top number 4 is the exponent that goes outside the radical. So that's c to the fourth power. And the remainder of 1 is the exponent that stays inside the radical. And that's just plain c. And that's as far as we can simplify. Any questions on campus? Let's look at one more example with the higher root and also a couple of letters. We have the cube root of 250, w to the third power, and m as in Mary to the 20th power. And the directions will say simplify your radical. 250 itself is not a perfect cube root, but one of its factors actually is. Break down 250 as 125 times 2. We know the cube root of 125. You can even figure that out mentally by asking yourself, what number can you multiply 3 times to make 125? And that, of course, would be 5. So 5 goes outside the radical. Leave some room in case you have to pull out some of the letters. And that 2 stays inside the radical. Now let's break down the W. We'll divide 3 into 3. According to our division, that 1 means we'll pull out just a W to the first power. And the bottom number, the remainder, tells us no W's remain inside the radical. Now let's break down the M in similar fashion. We'll divide 3 into 20. That will go 6 times with a remainder of 2. The top number is the exponent that goes outside the radical, namely m to the 6th power. And the remainder tells you the exponent that remains inside the radical, meaning m squared. That's it. Later on today or the next day, once the video is finished processing, I will upload it to the announcements page in Blackboard. Oops.